An atom is the smallest unit of matter that cannot be divided further by chemical means. Everything around us, solids, liquids, gases, is made of atoms. It is the basic unit that makes up all substances. A group of atoms joined together is called a molecule. For example, a single drop of water contains millions of water molecules, and each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Now let's understand what an atom is made of. Every atom has a central nucleus, which contains 2 types of particles, protons and neutrons. Protons are positively charged particles, while neutrons have no charge. They are neutral. Surrounding the nucleus are very tiny negatively charged particles called electrons, which move in orbits or shells. In a neutral atom, the number of protons and electrons is always equal, so their charges cancel out. For example, a carbon atom has 6 protons and 6 electrons, making it electrically neutral. Each atom is identified by its atomic number, which is the number of protons in its nucleus. The mass number is the total number of protons and neutrons in the atom. For example, the atomic number of carbon is 6 because it has 6 protons, and its mass number is 12 because it has 6 protons and 6 neutrons. Every element is represented by a unique chemical symbol. These symbols are usually 1 or 2 letters. The first letter is always capital, and if there is a second letter, it is lowercase. For example, H stands for hydrogen, O for oxygen, Na for sodium, from its Latin name natrium, and Cl for chlorine. These symbols help us write chemical formulas in a short and easy way. Next comes the idea of valency, which tells us how an atom can combine with other atoms. Valency is the combining capacity of an element and is related to the number of electrons in the outermost shell of an atom. Atoms try to become stable by gaining, losing, or sharing electrons to fill their outer shells. For example, hydrogen has 1 electron in its outer shell, so its valency is 1. Oxygen has 6 electrons in its outer shell and needs 2 more to become stable, so its valency is 2. Similarly, carbon has 4 outer electrons and a valency of 4. Sodium has 1 electron in its outer shell and has a valency of 1, while chlorine has 7 electrons in its outer shell and a valency of 1. Chemical formulas show which elements are present in a compound and in what ratio. For example, H2O is the chemical formula for water, which means it has 2 hydrogen atoms and 1 oxygen atom. CO2 stands for carbon dioxide, which has 1 carbon and 2 oxygen atoms. NaCl is the formula for common salt, showing 1 sodium and 1 chlorine atom. To write chemical formulas, we often use the valency cross method. For example, magnesium has a valency of 2 and chlorine has a valency of 1. When they combine, the formula becomes MgCl2, showing that 1 magnesium atom joins with 2 chlorine atoms. Finally, let's understand the mole concept, which helps us count atoms and molecules easily. Atoms and molecules are extremely small and difficult to count individually, so scientists use a unit called the mole. 1 mole is equal to 6.022 into 10 to the power of 23 particles. This is called Avogadro's number. That means 1 mole of oxygen molecules contains 6.022 into 10 to the power of 23 molecules of oxygen. The mass of 1 mole of a substance, called molar mass, is equal to the atomic or molecular mass expressed in grams. For example, the molecular mass of water, H2O, is 18 U, so 1 mole of water weighs 18 grams. In summary, atoms are the basic building blocks of matter. They are made of protons, neutrons, and electrons. Elements are represented by symbols, and their combining capacity is called valency. Atoms form molecules by combining in fixed ratios, which are shown using chemical formulas. To handle large numbers of atoms and molecules, we use the mole concept, where 1 mole equals 6.022 into 10 to the power of 23 particles. These ideas help us understand the structure and behavior of all matter in chemistry. If you find this helpful, like, share and subscribe for more such videos.